2025 National 5 Paper 2 Question 8. A cuboid, and we're given points L and R, and we have to find M. Now pause the video if you wish to have a go at it, but otherwise I'm going to continue. So we have to use these points to then find M. So we know that we have the origin O, we have R is 4, 0, 0. So what that means is to go from O to R, you go along 4 in the X, along the X-axis in the positive direction to go from O to R. If you have a look here though at the Q, now Q is parallel to OP, the RQ, the line from R to Q is parallel to the line O to P, but O to P goes along the y-axis, so the x coordinate doesn't change. So the same idea happens with RQ. It goes along parallel to the y-axis, so the x coordinate doesn't change. So let's find out the coordinates of Q first of all. So as you see, the x coordinate to go to Q does not change because the line RQ is parallel to OP. So that is 4. And because it's a cuboid, RQ must be the same length as OP. If we have a look here, I know this gets confusing. LP is that edge. Now that edge is parallel to the z-axis. It's parallel to the z-axis, so we know that if you go down from L to P, the only point that can change is the z coordinate. And P is along the y-axis, so the z coordinate of P must be 0, so the point P is 0, 3, 0. So it means it's going nothing along the x-axis, it goes 3 in the positive direction of the y-axis and nothing up the z-axis. And Q, RQ must be the same length as OP as we said, so to go from O to P you go 3 along in the positive y-axis direction, so it's the same R to Q, so we go along 3, so the y coordinate goes up by 3 and we don't move along the z-axis. And M, now you see that to go from P to L you go 12 up the z-axis. Well, logically, because it's a cuboid, that edge, I'm going to mark these in, put this one in green, nope, do it in this colour. This edge, this edge, and this edge, those 4 edges must be the same length. So this must be 12, the edge Q to M, and only moves in the direct, and it's parallel to the z-axis. So the only coordinate that's changing is the z coordinate. So that means it goes up 12 in the z axis, but none of the other coordinates change. The x and the y coordinates don't change. So we get m is 4, 3, 12. So that is 4, 3, 12. So part B, pause the video if you want to have a go at it, but here goes. Calculate the length of the space diagonal OM. Now there's two ways we can think about this one. We can think about it in terms of vectors, or we can think about it in terms of Pythagoras. Let's first of all have a look at this in terms of vectors. They're very similar methods, but they're a bit different. We're going to find the magnitude of the vector OM. So that is the vector going from O to M, and the magnitude of this vector will be the length of the space diagonal. And then what we want to do is we're going to use position vectors. So we'll do the position vector of M minus the position vector of O. We'll use the small letters with the underline for the position vectors. Now to write the position vector of small m, you write it as a column instead of a row, like this. And that's the origin, so that's 0, 0, 0. You just write each point in a column instead of a row like this. We write it in a column, and that gives us 4, 3, and 12. So we have an x, a y, and a z component. So if a vector is of this form, x, y, z, then the magnitude is given by the square root of x squared plus y squared plus z squared. So we get the square root of 4 squared plus 3 squared plus 12 squared. And doing this on the calculator would give you the square root of 169. So that would be 13. And we're not given any units in the question, so we will just write down units, and that's 13 units. And that's us done. But let's think about it in terms of Pythagoras' theorem. It's evident from the diagram, and we're also told explicitly in the question that OM is a space diagonal. What that means is the corners O and M are two furthest away. So for example, R and L. RL makes a space diagonal because R and L are the furthest away you can get, but there's other pairs that make up a space diagonal. In layman's terms, OM represents the longest possible distance that you can go from one end to the other of a cuboid. If you had a rod and you put a rod between O and M and it fitted perfectly, then you could not possibly fit in a larger rod. That's the best way to think about it. If that rod, there was no gap and it fit in perfectly, then you would not be able to get a larger rod inside the cuboid. So we know using Pythagoras that for a space diagonal, the formula is the length squared plus the breadth squared plus the height squared. That's the formula for the space diagonal in three-dimensional Pythagoras. But I won't even do this whole one because it's pretty much the same thing as what we've done, but there's no need to actually go through this fully. But go along 4, then along 3, then 12. So you've got dimensions 4, 3, and 12. So if you substitute 4, 3, and 12, you get 4 squared plus 3 squared, and the height is 12. And we get the exact same thing happening. So let's have a look at how the SQA would mark this question. Let's just have a look. Now in question A, you would get the mark if you got 4, 3, 12. If you wrote it as a column vector, so have a look at this. It's a bit highlighted. This would give you nothing because that's a position vector. That's a vector. It's not the point. It's asking for the point. And if we have a look at this section B, the first mark would be for starting a valid strategy and continuing it. So this would be 2 marks by this point. It's not very clear where the first mark is given and where the second mark is, but let's just say that once you get to this point, you get 2 marks, and the last mark is for getting 13. You would get no marks if you did this without working, because it's pretty easy to do this question in your head, but they're not assessing mental arithmetic, they are assessing your ability to use vectors, so you have to show exactly what you're doing. You could also do this a few other ways. You could use your knowledge of Pythagorean triples. You could use these Pythagorean triples to help you. And many candidates made the mistake of adding the 4 and the 3, then doing the square root of 7 squared plus 12 squared. That's not how you do three-dimensional Pythagoras. You've got the dimensions 4, 3, and 12, so you have to do the squares of all of the dimensions, adding them up, then taking the square root of it. Many other pupils found 4 lengths but that makes no sense because it's a three-dimensional shape, and to find the space diagonal, if you want to find the space diagonal of a cuboid, you simply have to learn the formula and understand it. Because a cuboid has three dimensions. It's got a length, a breadth, and a height. They might be the same. You might have two of the exact same numbers, but you can't possibly have four dimensions in a cuboid. So this made no sense. It's mathematically incorrect. Other pupils found what's called a face diagonal, and a face diagonal is, if you look along a face, as the name suggests, O to N, for instance, would be a face diagonal. So this would be a face diagonal, and M to R, so along this face, this here would also be a face diagonal. Like that. So, I hope you found this video useful. It's quite a challenging question, especially having to visualise part A and figure out point M. But as long as you don't make the working too easy for yourself in section B, if you get section A wrong, it's 1 mark lost. You can still go on to score well in section B with a follow through. The only thing is, if you make the answer to M such that B is really easy. So for example, if you wrote that M is, I don't know, 0, 0, 0, and you said M was the origin. Now, that is nonsense. But suppose you wrote that, then you found that the length was 0 because M is 0, 0, 0 and O is 0, 0, 0. Well, that's what you write down. Then you would be right based on the wrong answer you gave in section A, but you've made it too easy for yourself, so they can't award marks. But generally, you can still pick up marks with an incorrect answer. So I hope you found this useful, and thank you for watching. Best of luck with the studying.